We're talking about the fundamental theorem of algebra, and we're trying to find the zeros for particular functions. And this time we're going to use a little bit of technology to help us do this a little bit quicker. Tachometer measures the speed in revolutions per minute, or RPM, at which an engine shaft rotates. For a certain boat, the speed x in hundreds of RPMs of the engine shaft and the speed s in miles per hour of the boat are modeled by, so we have miles per hour, and the x is the RPMs, and then it's modeled by that equation. So we want to find what is the tachometer reading when the boat travels 15 miles per hour. And so what we want to do is we want to take our equation that we have right here that's given to us, and we want to substitute in what we know. And we know for this case that the boat travels 15 miles per hour. So that goes in for our S value. So I'm going to substitute 15 in for S, and then we'll write down the rest of the equation just as it is there. 0.00547 x cubed minus 0.225 x squared plus 3.62x minus 11.0. And then what we want to do is we want to find the zero. So in order to find the zero, we need to find when the y value, or when this polynomial, is going to be equal to 0. So we can subtract 15 from both sides. And then we'll rewrite the function 0.00547 x cubed minus 0.225 x squared plus 3.62x minus 26. Okay. So what we're looking for is what value we can substitute in for x that will make this whole function equal to 0. And so we want to use our graphing calculator, and so we can see that right there. We'll just zoom out just a little bit. And if I tilt it towards the light a little bit, we can see a little more. So what we want to do is we want to type that equation into y equals. And I've already done that. And then we can go to our graph. And we have the graph there. And we can see that it crosses the x-axis. And so we want to calculate that, so we can hit second calc. And we want to find the 0. So I'll go down to the 0, and I'm going to hit enter at the bottom of the calculator. And then it's going to give us some directions. So right there it says left bound. So it wants us to be on the x, for the x value to be left of that intersection point. So we'll scroll to the left, and we can see the intersection point is there, and that's some x value. And we know that our x-intercept is to the left, or the x value of this point is to the left of that. So I'm going to hit enter. And then you see that an arrow pops up on top of the screen. Now it says be to the right of the intersection. So I'm going to scroll to the right, and we can see that the intersection happens about there, and I want to be a little bit further to the right of that. So now I'm going to hit enter, and we see that another arrow shows up on the screen, and our intersection point is between the left bound and the right bound that we created. And now it says our third step says guess. And so we want to guess where the intersection happens. It doesn't have to be exact. We're just guessing. So we highlight it and hit enter. And then it tells us that the intersection is 19.863 or 19.863, which is shown there. And so from the graph, we find the 0. The 0 is 19.863, 0, and that represents the boat speed. Represents the boat's speed. Of 15 miles per hour. That tells us the engine must have an RPM of 19,863. That's because the X's are measured in hundreds of RPM. And we can look at the graph a little bit cleaner, and we can see that it is at 19.863 right there.